and welcome to the demo of the Datadog Mule integrations. We are IA Connect services. We have more than 20 years of professional experience, and we are a Datadog MuleSoft and AWS partner. MuleSoft was one of our first partners, and while handling Mule projects with different customers, the idea of these products was born because of the pain points we usually notice during our engagements. Long story short, we became a Datadog partner, and now we have multiple products in Datadog's marketplace. We have two different products in Datadog's marketplace for Mule monitoring, and they complement each other since they monitor different aspects of Mule apps and the Anypoint platform. The first product, Datadog Mule Integration, or DMI, monitors the infrastructure of your Anypoint platform. It collects the information from your Anypoint platform and converts that information into Datadog metrics that can be used to create dashboards and monitors for alerts. The second product, DMI for APM, focuses on application metrics. We actually provide a Mule connector, the Datadog APM Connector, which needs to be used to instrument your Mule applications for you to be able to send APM metrics into Datadog and track execution times, bottlenecks, troubleshoot, and trace logs. Restating, both products monitor different aspects. The first, DMI, takes care of the infrastructure side of things. And the second one, DMI for APM, monitors application metrics and logs. It is important to mention the first product doesn't involve code change. It is almost a plug and play. The second one does require code change, but more of that later. Let's dive deeper into the first product, DMI. At the moment DMI product is installed, it will start populating information from multiple Anypoint platform tools into Datadog metrics. These 150 plus metrics are control plane metrics about API analytics, API manager, with information such as policies, API operations, hits, latency, geolocation, status codes, request response time, and sizes. Access management, like active resources that are part of your license, such as P-cores and VPNs, Exchange with useful metrics to establish your C4E like published assets, object store and its usage, some runtime metrics like CPU, memory, network, app name, app started, app stopped. All these metrics include tags that can help you correlate them. One note though on the runtime metrics, the runtime metrics available depend on the runtime model that you have. CloudHub, CloudHub 2.0, RTF, or standalone on premises. These 100 plus metrics have been categorized in 8 predefined dashboards out of the box. Each dashboard has been crafted for different roles, considering what interests they have in mind: operation, development, and executive teams. These dashboards will be available at the moment of installation and can be cloned and fully tailored to your organization needs. Let's take a deeper look at the API dashboard. The API dashboard gives you information such as request and response size, response times, and response status. This information can be aggregated to display total requests per API, total failed requests per API. There's also information on the API like the resource requested, status code responded, success and failed request response sizes, and response times based on the response status. If we go to the top right, we're going to see failed requests for API or top fail APIs. The API's dashboard will populate information regardless of the deployment model your company uses: CloudHub, CloudHub 2.0, RTF, or standalone. Next dashboard is the cost optimization. Some of the problems executives often face are the lack of visibility of the entitled MuleSoft resources, how hard it is to forecast the usage of these resources in the future, and they have minimum visibility to failures and downtime, making it hard to calculate the business impact. The Datadog Mule integration offers an out-of-the-box dashboard with this kind of visibility. The cost optimization dashboard provides two important views to executives: an historical view of the applications that have failed, as well as the top failed applications and servers list. These helps you understand the historical downtime and measure how this impacts the business. And an easy to understand visual representation of the resources entitled in the MuleSoft license. This visualization immediately gives hard numbers for the current date and also a timeline showing the usage patterns over time. This helps you identify ups and downs in the usage of the resources. In the first group, it shows the applications and server failures, in which stop applications and servers are shown in a time series graphic for historical analysis, showing how much time applications have been stopped. This also shows a list of the top 10 applications that have been stopped the most time. The second group has in green the used resources, in red the unused resources, and at the right a time series graphic showing the historical usage pattern. The layout first shows the vCores by environment, production, sandbox, and design. If the numbers of vCores in production have changed, assigning more vCores to this organization, this means that the engineering team is making use of the licensed MuleSoft products, a good sign of the return of investment. However, if the time series trend is decreasing, then it means that the resources have been decommissioned. Below, other resources are shown with a similar pattern, such as VPNs, VPCs, static IPs, load balancers, premium connectors, and object store operations in the MuleSoft license. Note that the entitlement of these resources is not associated to any environment. Next is the operations, resource allocation, and usage dashboard. For operations teams, it is common they must know how many resources they have available to support more applications, regardless of the environment. In any point platform, there are two concepts with regarding resource allocation. Assign means purchased or licensed resources that are usable by the current organization. Reassign means resources allocated to a suborganization. A suborganization is an organization under a parent organization, and it can be a department, line of business, region, etc. The Datadog Mule Integration offers an out-of-the-box dashboard with this kind of visibility. The Resources Allocation and Usage dashboard provides immediate insights about how the resources are allocated in the organization as well as suborganizations, and how many are still available to be used. We can see in the first group organization vCores. It shows the vCores assigned to the parent organization in production, sandbox, and design environments, and shows how many vCores are reassigned to its direct suborganizations, if any. The next group of tables shows the used resources per environment in the current organization. These resources are VPNs, VPCs, load balancers, and static IPs and object store. Next, we have the Operations Infrastructure Dashboard. Operations teams are the ones in charge of keeping all IT infrastructure and operations in good health. They must know almost instantaneously when an application failed or when a server or application has stopped working. The Datadog Mule integration offers a set of out-of-the-box monitors and dashboards to help operations teams to quickly gain this kind of visibility in a single source of truth, rather than navigating multiple pages. The dashboard is divided in three groups. The critical group shows all applications and servers that have failed or errored. These widgets are fed using events produced by the monitors shown before. Stopped applications, stop or disconnected servers, applications with errors, and overloaded queues. Next is the CloudHub group that shows graphics about the applications running in CloudHub. Using the application and environment ID controls at the top, you can get a granular view to a single instance or the environment. If filtering by environment, the graphics will show aggregated averages of all applications running in such environment. The metrics shown are consumed memory, CPU usage, network in and out, and messages queued and in flight in the application. In the last group, we have on-premise, which shows the same graphics as the CloudHub group, except the messages queued and in flight. This group can be filtered out by the target name or host. This dashboard is available only with CloudHub and standalone deployment models. It is not available for CloudHub 2.0 at the present moment. Up next, the Development Optimizations dashboard. It is common that integration solutions are blamed for poor performance, when in fact, it is one of the downstream services, the real bottleneck. It is hard for developers to chase and identify these kind of problems because they occur under very specific environments, contexts, and situations. The Development Optimizations dashboard offers a single source of truth for developers, allowing them to query for specific conditions in a given period of time. It has a set of controls at the top to allow you to organize the views for application, environment ID, target name, and host. The CloudHub group shows graphics about the applications running in CloudHub using the application and environment ID controls at the top. You can get a granular view to a single instance or environment. If filtering by environment, the graphics will show aggregated averages of all applications running in such environment. So for example, if the operations team has complained about a performance problem at a specific point in time, using the timeline, you can specify a time range looking for abnormalities or spikes. And you can even drill down a specific time range by selecting the ranging graphics. This will synchronize all the graphics in the dashboard to this time range. And also, this can be done in the on-premise group below. This dashboard is available only with CloudHub and standalone deployment models. It is not available for CloudHub 2.0 at the present moment. And lastly, we have the Operations Private Spaces overview. This dashboard is specific to CloudHub 2.0 and the infrastructure around its private spaces. With this dashboard, you will be able to tell if you have unavailable private spaces or issues in the VPN connection or tunnel. In the second section, you will be able to visualize the private space settings like firewall inbound and outbound rules. Besides dashboards, a set of monitors are created when the Datadog Mule integration is configured for the first time. These monitors come with pre-configured thresholds and conditions for applications stop and running, on-premises, and in CloudHub, high memory and CPU consumption, application errors, overloaded VM queues in CloudHub applications, disconnected Mule servers running on-premises. These monitors can be configured to send notifications to your team through email, Slack, PagerDuty, and other notification systems. As with dashboards, these monitors are predefined but can be cloned, customized, or brand new monitors can be created with the metrics provided. If you have any questions around installation and pricing, please visit the Datadog Marketplace documentation, the IA Connect official documentation, or contact us at products.sales at iaconnectservices.com and support_DDP at iaconnectservices.com to better assist you. And please note, we do have a 14-day trial period. In the previous section, we have just talked about DMI, the first out of the two products, which monitors the Anypoint Platform infrastructure aspect. Now, let's talk about the second product, DMI for APM, which focuses on application metrics. As part of the Datadog Mule integration for APM, a Mule connector is provided, the Datadog APM Connector, which needs to be used to instrument your Mule applications so you can send API metrics into Datadog and be able to track execution times, bottlenecks, troubleshoot, and trace errors via logs. This product works for every deployment model, CloudHub, CloudHub 2.0, RTF, and standalone, as it runs directly in your Mule applications. And before we continue answering your first question, yes, this means that your Mule application does require code change. How do I need to configure my Mule apps then? More to that on the next slide. The Datadog APM connector will allow you to have end-to-end tracing of your Mule flows across Mule apps and even across different services that support APM as well, since the connector supports distributed tracing. Once you determine which are the key points that need to be monitored in your Mule apps, you'll have to use the APM connector operations and enclose them with the create and finish span operations to be able to trace them and see them visually represented as spans. Spans will have a duration that will help you to detect potential bottlenecks. The connector also has a logger operation based directly on the standard logger element, which not only logs, but also associates the logs with the traces and spans they were created under, so you can quickly troubleshoot with the power of APM. Here in the slide, you can see an extract of a flow instrumented with the Mule connector. There is a create span operation, a finish span operation, and the logger one. And in here, you can see the visual representation of the spans created by the connector in Datadog APM in its flame graph view. This example represents a set of span across 4 different Mule APIs, and you can see the duration of the overall business transaction across all of the layers in one view. And you can see the duration of each layer and its operations, allowing you to detect quickly which operation is taking the most time to complete and thus impacting your overall execution times. Because this is a manual instrumentation that the connector provides, depending on your business flow, you can get as high level or as granular as needed. And the logs too will be available to be traced across Mule apps as well. Let's take a closer look at the demo with APM. Before we switch to Datadog, please consider the following scenario, which is a very basic API-led connectivity approach use case. We have one experience layer, which calls a process layer. This process layer will call the first system to retrieve data. It will validate the retrieved data, and if valid, it will make a call to the second system API. And across the full Mule APIs, we're propagating the correlation ID. Here in the Datadog platform, let's navigate to Logs, Logs Explorer. And we're going to be able to find the logs of multiple services across different Mule apps, across other services that are not necessarily Mule apps. And this is one main difference you're going to notice right away if you are an endpoint platform user and are not in the Titanium subscription. You will see that your logs are across Mule APIs all in one view versus having to navigate to each individual tab to check the logs. And we can filter and deselect or select these services. So you can see the logs for 1, 2, 3 different services. You can also filter here by status and some other filters out of the box. In here, we're interested in this messaging process layer, marketing experience layer, contact system layer, and this Twilio SAP even. And while I have a sea of logs in here, I am going to choose a random messaging layer logger, messaging process layer logger. And in the event attribute section of it, I'm going to see besides the logging message in here, I'm going to be able to see the app name, level, and very importantly, the correlation ID. This is what we mentioned. We are propagating across the 4 Mule different layers. We are propagating this correlation ID across them, so it will help us make filters in Datadog across the 4 different Mule apps because the transaction will share this correlation ID across the layers. How will this correlation ID help me to be able to identify logs or find them? I just chose, again, a random logger in here, just clicked on it, and I can see, before I do any kind of filtering, logs of a lot of services and a lot of transactions, because in this demo environment, we have them coming every minute. If we click on the cog of correlation ID and do a filter by correlation ID, closing this pane, we're going to be able to see across the 4 different layers all of the logs associated to that specific correlation ID that we chose. So if we do know the correlation ID for a transaction, we're going to be able to use it to filter in here. And instead of getting all of the logs everywhere all at once, we're going to be able to see just the logs of that transaction. And while this is very nice and all, I might not know the correlation ID that I'm looking for, but I may know a customer ID, an order ID, a flight ID, some kind of ID that first can help me identify the very specific issue that I want to troubleshoot. So I'm going to clear this filter up top, and I am going to type a customer ID that I know that is in my logs. So the first search that I do is going to be based on an ID that I know, which is the customer ID. Then I can click on this log, and yes, we're going to have the correlation ID now associated to this customer ID. So then I filter by it. And one last thing, I go back to my search bar, remove the customer ID to just keep the correlation ID. And this is how I get from an ID that I know all of the logs associated to that very specific transaction. And a very common question is, what can I log? And the answer is whatever you can log in your standard logger element from Mule, we follow the exact same thing. The logger from the Mule connector is the exact same thing. And we're going to see that later on when we go to an Anypoint Studio, so I can show you how it looks like for a Mule app. And this is how the loggers look like. But now let's navigate to APM Traces Explorer to talk about spans, which is the other thing that our Mule connector allows you to do. Again, here I can see services that I have multiple other services besides the 4 ones that I need. Same deal as for the logs. I can select or deselect the services that I do not need at this moment and just keep the ones that I want to see. I can also do that filtering based on status of error and OK, and some other ones like the resource here below. What I can see right now is all of my spans are being listed. Again, in this demo environment, we have this running every minute. That's why we see a lot of information come in, successful, and obviously errors that we created on purpose for this. I am going to make a pause to these traces so I can actually show you with more detail how the spans look like. And first of all, visually, I can see that I have successful information because I do see this green line in here, and I have this red one because I also have some errors. Let's go first to a successful scenario, and then I'll show you how it helps you to have these spans for an error. If I pick this process layer span, and we go to the flame graph view, this is the power of using the APM connector. I just clicked a random span of a process layer, but I am able to tell visually that this process executed as I expected it, because I can see in one view that what triggered all of this is the call from my experience layer. And then a call to my process layer was made. Then I made a call to the first system layer as I expect. Then I made an internal validation in the process layer. And then I made the call to the second system layer. This is the kind of information that you will be able to see like visually, very quick, right away, that it behaved as expected. But not only that, not only is about if my layers executed, but how long they took to execute. In this case, we can see that if we ever want to be able to do an enhancement on our response times to see why a specific transaction is taking so long because I want to be able to do it quicker, this kind of visibility will let us know, okay, the experience layer is taking this much time, above 700 milliseconds, but I can see that behind all this is because the system layer took a long time to execute, even more than the request to the database, the query to the database. This call to the Twilio API it is taking a long time. So maybe if I ever want to enhance this process, this is where I need to take a look. Besides giving us the span information, the span list of all of this spans that we created, we can also see a map. This map is showing us how the layers communicate to each other. How we have our experience layer, our process layer that made a call to our system layer and then to the other one. Going back to the flame graph, we can see in here also the 4 Mule APIs that talk to each other. And if we go to the section below, we're going to be able to see, before the overview, let me show you the logs. If we switch to the logs tab, I do have the logs available for this very specific transaction that I chose. So instead of having all of the logs everywhere, for this very specific random process ID that I took, I can see the whole picture of all of the layers, how long they took, and the logs associated to this very specific transaction. And the logs are also across the 4 Mule layers. We can see in here that we have the experience call, the process one, and then how process made a call to the first system, that the validation was successful in my process layer, and that's why I made the call to my second system layer, and then how everything finished successfully. If we switch to the overview section, we're going to see in here the tags. And these tags will let us inject values that are key for us to be able to search data or filter data. For example, the correlation ID. If I do this filter by correlation ID, let me click on this pane to close it. Same as for the logs, I am able to filter all of the spans associated to this correlation ID that I am propagating through layers. And just as we did for this correlation ID, through the Mule connector, you will be able to inject whatever IDs are very useful to you to be able to do this kind of search. Your own, your order ID, your customer ID, your travel ID, your reservation ID, whatever IDs make sense for you to be able to do queries to these traces and to these logs. Besides that, we have some other tags that can be populated through the connector, like the HTTP method, status code of this response, and some other information. Now, this is very nice and all for a successful scenario, but how can this help me to detect a problem, to see where the problem was when something went wrong? Let's clear the filters that we have. So I removed the correlation ID, just kept the services that we're interested into. And I will start again the stream here at the top so we can have some more new transactions coming. I will pause it again because now we'll go to an error scenario. What can we do? Like, first of all, like super quick right away to detect. We can use the status filter. We can remove the OK. And we're going to be able to see like all of the errors that we have right now in whichever layer they occurred. We can see the service name right here, right now. If I choose this first error in here, this process layer in here, because I want to see what went wrong. What is the first thing we're going to notice? Like, again, right away, very visual, is that this flame graph doesn't look like the other one. It doesn't look like what we're expecting, which is to have a call to 4 Mule APIs. Actually, we can see in the list in here of the services of the Mule APIs, we only have calls to 3 of them: context happy, marketing experience, and messaging process. So what can we tell? Before doing any further research, the call to my second system API did not happen. And it should have happened. So then what is it that I can do? I can go to the logs, I can click on them, and then I can try to figure out where it all went wrong, which is the experience layer started, it called it the process layer, the system layer, try to make the call to this database that we have, and then, okay, the information from the database was contact information uh, of a not found member. So then, if we don't have this contact information that we expect, we cannot go further. We cannot call the second system API. So then we stopped right here because in my process layer, I detected that from the response from the first system, I don't have what I need in order to be able to call the second system API. So I will not. You can see how quick this process was. We just chose one of the random errors in here. We can see across the 4 Mule APIs how visually easy for us was to detect that something's not okay, that one of the layers was not called, and then how the associated logs told us what we needed to know, which is that the call did not occur because we didn't find the information that we were expecting. I'm going to close it. And I am going to choose a different error in here. I can see this is a 500. And yet again, I can see visually, I do not have the 4 API calls that I expect. I can see that the call to the 4 API didn't happen, to the 4th one. So then we open the logs window. We see that it started, experience, process, call to the first system. The database was called. I did find the contact information this time. So then what happened? That the process layer has a validation to validate that phone number that came back, and the validation did not pass. So this time, we did find the information we were looking for in the database, in the first system. That wasn't the problem anymore. The problem was different. The problem is that we have an internal validation that will also stop us to, and we're not going to make the call to the second system API. This is what happened now. And yet again, this is log information. Information around any ID can be added in here. This is the standard logger operation just through the Mule Connector logger. And in here, in span tags, we can inject any tag that helps you to be able to troubleshoot your logs and your spans. And as last notes here on the Datadog platform, everything that we add in here, that we switch between status or a service or resources, is added here at the top bar in the search bar. If you want to have a specific set of query predefined, you can do that. You can do anything that Datadog allows you. And also, while in here, we only saw the paths across 4 Mule APIs, as mentioned, the connector supports distributed tracing. So if you happen to have a front end or any other services that support APM, as long as you inject the context into the Mule APIs, you will be able to see all of your transaction flows end to end through all of your services, not only Mule APIs. Okay. So now I'll be moving on to the next interesting thing to you, which is let's go and see how a Mule flow looks like and what you might need to do in order for you to be able to see all of this information like this. Now here in Anypoint Studio, you can see that I have the 4 layers loaded from the demo. We have the marketing experience layer, the messaging process, Twilio system, and contact system. Let's open the messaging process layer. And you can see that as part of this Mule app, I have loaded the Datadog APM Connector. If we want to see what kind of operations that are available in the connector, here in Anypoint Studio in the palette, when I click in Datadog APM, you can see the available operations, which is dimension create span, finish span, and logger. We do have some other operations which we encourage for you to go and read the official connector documentation that we have. And now, how do I use these operations in a Mule flow? In here, we can find a standard flow. In this flow, you can see that I have at the beginning of it a create span operation. And at the end of it, I have a finish span operation. This will allow me to detect duration of the whole flow. Like whatever happens in between will be captured by this create span and finish span. I'm going to know the duration of everything. However, I do have 2 different requests in my process layer. I have the request to my first system layer. I have the validation that we have seen error out before. And I have the request to my second system layer. That's why you're going to see in this flow that in closing each request, I do have a child create and finish span. Once again, I have the create and finish span at the level of the whole flow, just the whole thing from beginning to end. I have one create span from beginning to end. And then around the first request, I have a create span and a finish span. And around the second request, I also have a create span and a finish span. What this will allow me to see visually in Datadog is how long did my whole execution in the process layer took, and then how long is it taking for each system call to be done. This is the kind of information that I might need to see for me to be able to detect if the execution is happening as expected and also how long it is taking. It is up to you and what you consider the best points to trace how many create and finish spans you have in your Mule flow. You can see in here that at least as a baseline, you can put a create and finish span at the level of your whole flow, and then another one around calls to other services or other APIs. And in here, we have multiple loggers, way more than one may usually have, but this is just to illustrate the point. And a very common question is, what can I send in my Mule logger? I'm going to click on it to see the details. And you will find that this is very, very similar to the standard logger operation. In here, we have a display name. We have a message that it can be a static string or it can be data weave, same as the standard logger element. I have my log levels. I can assign a category. The tiny things that are different is that this message is associated to a span name. You'll remember that when we clicked on a span, we were not only able to see all of the spans across the Mule layers, but we were able to see the very specific set of logs associated to those specific spans, to that specific transaction. This span name association is what makes it happen. We need to set the span name, and it needs to match the span where it belongs to. So now going to create span in here, we have a display name. I'm going to go a little bit later on the connector configuration. I'm going to go there next. And here we have a span name. In here, you can put any text that makes sense for you to then visually see what is it that you're tracing. And this span name is the one that needs to match the logger span name. This is what makes the association happen. And in here, besides setting a name, which is the bare minimum of what's needed, in here is where we can inject tags. Now, tags can be injected at two different levels. It can be injected at the level of this span in here, or because we support distributed tracing, it can be injected as a baggage item. And the advantage of it is that once you inject a tag as a baggage item, it will be propagated across every create span. So you don't need to set it again and again and again and again. So for example, this correlation ID, you can set it as a baggage item once, and then in your next create span, you wouldn't need to set it again. If you want to set in here a specific order ID, reservation ID, this or here is the place to go. This is where you inject your very specific traces that will help you monitor and be able to filter your query. Okay, so back to the create span, we set a span name that needs to be used for the loggers element inside it. We have tags in which we can inject our own tags at the create span level or at the level of every other span nested in it. And in here below, we have our request tags. So this is additional information that it is optional for us to set, but the more information that you send over your create span, the clearer for you it will be to read what this span is relating to, what is the method, if this is an API operation, what is the URI path. Like the more information you have, the better, so you can have a clearer visibility. And as for your create span, I quickly show you this distributed tracing to talk about what information you can propagate across your other child create spans. But this is the place in which, if you have this process layer that is being called by an experience layer, or your experience layer is being called by a front end, and you want to have this visibility end to end that I just showed you, in which in one flame graph you can see everything, this section is the one that makes it happen. This section is the injection. And injection is where you, well, inject your trace context. You need to know the trace ID, the parent ID, and the sampling priority of whichever trace you are joining. So for example, because this is a call to our process layer, this layer is being called by my experience layer. So I need to make sure that my experience layer is sending this information to my process layer when the HTTP request is made. It can be sent as headers, it can be sent as part of the body, however way it needs to be sent across Mule APIs, as long as it is sent, your next Mule layer receives it, and then in your create span, you set it. Now, if I am in an experience layer, how do I send this? Okay, let's open real quick the experience layer to show you. This is my experience layer. I have here the request to the process layer. And in this request to the process, this is a standard request operation. But now take a look at this header section in my very standard process layer request. I am sending this variable, span details. Once again, this is my experience layer. My experience layer needs to send the trace information to my process layer. If this step is not done, each API layer will be completely independent from each other, and you will not be able to get the flame graph view of all of your Mule apps together. So then, I am sending this information as header, span details, but well, from where do I get this span details? Okay, so in my experience layer, when I create my first span, which in this case, experience is the place where my first span is created. If you have any other service calling this Mule app, that will be your originating place. And then you will just keep propagating it. But in this case, this is my first create span ever for my experience layer. So what do I do besides setting what we already talked about, which is a span name, HTTP method, correlation ID, and so on? In advanced, every create span, and this is a rule because of the contract of the create span. Once again, this is documented in the doc page, the IO Connect doc page. Every time a create span is used, it needs to set the target variable. And this target variable can be named however it makes sense, like span details, span context, and it needs to store the payload. It is very, very important that this variable is set, because if it's not set, it will override the payload. But we are not only storing it to not override the payload, we are also storing this information because this is the span context that we need to send to our process layer in here. Okay. Once again, my experience layer has a create span because I want to trace my experience layer. I set all of this information in the general tab, and then I make sure that I store this payload into a variable span detail so I don't overwrite anything, and also so I have the context in a variable because I need to send this information as a header or in the body or whichever makes sense, but it needs to be sent to the downstream layer. So now switching back to my process layer, in my process layer, I received it as a header because that's how the experience layer sent it, as a header. And in this case, so I can actually join that existing trace in my headers. Now I have the details of what I need, but I actually need to go back to this distributed tracing tab and assign those values that I have in headers in here. And also in advance, I store these details again. And this is a rule because this is a contract of the create span. It has to be stored. Even if I don't want to use distributed tracing, it has to be stored so I don't overwrite the payload. Okay, pausing for a little bit, I show you how the experience layer looks like. I show you how the process layer looks like in terms of the first create span. My experience layer in here has a create and finish span. In my create span, I make sure that I store those details that then I need to send over to my process layer, which I will receive as headers because that's how I set it. In distributed tracing, I make sure I receive them, but I also set everything that I need to from the general tab, which is how is my span name going to look like and whatever tags are important to me to be able to use for later filtering of the information, like at least a correlation ID and maybe any other ID important to you. Now you'll remember that we have this structure on parent spans, child spans, how in the flame graph, they all look together. I'm going to switch back to Datadog to show you. Just going to click again on stream in here. We have this parent span, this child span. So how do we make this structure work? Going back to Anypoint Studio. This happens because my first create span, once again, it has a name. I need to use that name in my logger, span name 2. And also, this other create span is going to know that it should be a child of the first create span in this flow, because in here, I'm going to use as a parent the name of my first create span. Once again, I have my first create span in here. I have my span name, post messages, messaging pappy. And then if I check my second create span, which is my child create span, I'm going to have in here as parent the messaging pappy span. Well, I have a new name for this span, which is this is the SAPI span. And as usual, I have my tags in here, my request tags. And I'm always setting this target variable as whatever name makes sense for you, span details, span context, whatever's needed. In this case, in distributed tracing, you'll notice I do not need to send all of the headers that I did for the first span. I only did it for the first span because this is the first one in this Mule app. But since this SAPI span, is a child of the first process span, I only need to do this once. Now this create span, it has become a child of this one, so I do not need to set all of this again. And the last important thing to know about this span name, besides that it has to be set for the logger, for the loggers in here, you can see, is that when I finish this span, what I need to know is which span name I am closing, which is based on the span name. So for my request, I opened it in here. I am closing it in here. For my second child, I am opening one child and then closing it in here. And then at the very end, I am closing the last parent for this process layer. I'm closing it in here. And usually the next question is, okay, we have seen this connector configuration in here for create span and for logger. What is this about? Let's click on edit to see the global configuration of the Datadog connector. And you will find that you need a host and a port. Where are you going to get those details from? Well, that is part of the documentation information that we have for APM in the official IA Connect documentation. You can find the links in the last slide of this presentation. And also real quick in here, this is where the Datadog connector is. It's going to be embedded in a Mule app somewhere, wherever you have it. Because again, this Datadog APM solution doesn't matter if you're in CloudHub, CloudHub 2.0, Rented Fabric, on-premise, whatever you are, you're going to be using that connector in your Mule apps. And then you need to be able to send information to a Datadog agent running the integration. This might be too technical at this moment to just check the documentation, but this is where you will get the information on the host. You do need to have a server somewhere in the world, not a Mule server, a server somewhere in the world that will receive the information of your span, and then it will forward it to Datadog. So this is where you will get your host and port. They are the host and port of your Datadog agent with the integration running, with the Datadog Mule for APM integration running. This is completely separate to the other Datadog Mule integration for infrastructure metrics. This is specific for APM. And you have these other values which will serve to, they need to be set and they will serve for you to be able to filter information. You'll remember the service name, which is the app name, environment, and version, which if we go back to the browser to show you in Datadog, is this information that you can see here in the left, service, which is very commonly your app name. And you also have a version in here and the environment, I think, in here above. This is what you set in here. And it is very important that this information matches exactly what you have in your log4j. If we open the log4j for the messaging process layer, we will find that for the logs to be sent to Datadog, yes, you do need a connector, but also you do need to set the log4j appender to send over your information to Datadog. It is a very common question, even if it's very recent, this concept that we just introduced of the Datadog agent. The logs do not travel through this Datadog agent. The logs go directly to Datadog through the appender, through the HTTP appender, through the intake logs endpoint. The logs go directly. It's just the traces information, which is just basically trace ID, parent ID, correlation ID. That information is the one that is being redirected through the Datadog agent. But logs, no, logs go directly. So besides needing the logger element, you do need to set up the log4j appender, in which you need to make sure you have the matching information in here for service. And also if you're using environment and version, make sure that you do have that matching exactly there. If not, then when you want to trace and correlate that information in Datadog, it's not going to look, you're not going to be able to find it. Whenever you add your log4j appender, also make sure that you actually add the appender reference in here. Showing you real quick how the experience layer has it, so I can show you how it looks like with the environment and the version as well. Okay. So then answering this question that you have, which is then what do I need to have in my Mule apps in order to be able to have this visibility in Datadog APM? You need the Mule connector, which the connector itself is publicly available. You'll find it in our documentation. You need this agent running with the integration in it. You can find the instructions to set that up in the documentation page. You need to set the global configuration in here with that host and port of your agent and this information on your app name, environment, and version. And then you need to instrument your Mule apps with this create and finish spans in your process. In this case, you'll see that we have it at the level of the whole flow, and then a couple others as child spans around requests to another layer. To create a span, you just need a span name That's the very minimum, and to set this variable to not override the information in the payload. If you do want to be part of distributed tracing, make sure you have the right propagation values, in this case, the right injection values for your create span. When using the logger element, make sure that it matches the span name that is in it. And when you close that finished span, make sure also that you're closing it correctly. Okay. And that is it for how you need to set everything in your Mule apps. If you have any questions around installation, pricing, please visit the Datadog Marketplace documentation, the IA Connect official documentation, or contact us at products.sales and support_DDP at iaconnectservices.com to better assist you. Please note, we do have a 14-day trial period available for this integration too. If you are interested in using the product, but also have limited resources for a quick go-to-market on this Mule Connector implementation, or you have like a quick POC that you need to run, we can help with that too. There is also in Datadog Marketplace a tile in there to help you to do this instrumentation. Please do not hesitate to contact us for any questions, and thank you for your time.